Hello everyone. In this video we will see how we can generate and visualize unit impulse signal in MATLAB platform. The impulse signal is a kind of signal which is there for a very short period of time at one moment. For say example, if we take a camera flash signal, the camera flash signal is there only at a short period of time, and before the flash and after the flash the signal is not going to be there, and this kind of signal is called as impulse signal. We can give one more example for impulse signal as lightning. So if we take a lightning, the lightning is there only for a very short period of time, and also it is going to create a big impact, and before the lightning and after the lightning the signal is not going to be there, right? Now let's see how this kind of signal can be represented mathematically, both in continuous time and discrete time. As we see here, the unit impulse signal can be represented mathematically in a continuous time by considering the signal is available at t equal to 0, the signal is not available and all the time. Similarly, in a discrete time, the signal is available only at n equal to 0 and all of the time the signal is not available. Now let's try to generate and visualize this signal in MATLAB. So first you just create a new script. So for that, click new and click this script. So this is going to create a new window where we are going to develop our program. So first you save this file by either clicking save option or Ctrl S option, and now just name your file. So I'm going to name my file as, let's say, impulse signal, right? So it is always best to start the MATLAB programming with a command clc, which is used to clear the command window. Maybe due to the previous run, the results may be displayed on the command window. So in order to clear this, we'll be using the command called clc, and followed by we'll be using a command called clear, which is used to clear all the variables which are created due to the previous run, right? Now we will see how we can build the impulse signal in MATLAB. As you look here, to build a impulse signal we need actually two variable, right? We need a time data, and then corresponding to the time we need a impulse data. Am I right? If you look here, we have a time data right from minus infinity to plus infinite. Then the amplitude is there only at time t equal to 0. So this we have to create it first. And similarly for a discrete time, we have to create n variables, right? First let's create a x-axis data, and then we make the corresponding amplitude, that is corresponding y-axis data. So first I do it for a continuous time frame. So for a continuous time frame, our x-axis data is all about time, so whichever range of minus infinity to plus infinity. So it is not it is not to declare the data from minus infinity to plus infinity on a MATLAB. So we have to fix some time frame, right? So I'm going to consider the time frame of within a limit between minus 10 to plus 10. So within the limit I want to generate a different time steps, right? So there are a number of ways you can create a vector by having a range between one number to other number in a MATLAB. So I'm going to use this command by taking a variable name. So I'm just going to consider the variable name as t equal to, initially you have to keep a starting number of your vector. So in our case, let's fix the starting number is minus 10. I want to create a time vector limit between minus 10 to plus 10, right? And then you keep a colon, followed by you have to declare the how much amount of number you want to increment from the previous number. So initial number is minus 10. From minus 10, how much you want to increment? So I want to increment, let's say, by 0.001. Okay, then again you keep colon, then you keep your final number, that is upper limit, right? So this command will create a row vector starting from minus 10 to plus 10. So initial number is minus 10 and then it increment by 0.001, and each time it goes up to 0.001 and it goes up to 10. If you look, typically it is going to generate around 20,001 data including the zero number, right? So this is actually now the x-axis data for a continuous time frame, right? Now I just keep a semicolon because I don't want to display this number on the command window. So let's command this as this is for a continuous time signal. Okay, similarly we will create for a discrete time. So when it comes to discrete time, the signal has to be like integer numbers, right? And should be like 0, 1 and -1, -2 and so on. Am I right? So let's keep the discrete time x-axis variable name as n, right? Again I want to create a row vector range between -10 to +10. So my initial number is -10, followed by I now want to keep a discrete number, so which means I need to have step size of only 1. Even if I'm not specifying this, it automatically take that step size as 1, right? So I just keep up to the maximum limit as now 10. So this is going to create row vector starting from -10, -9, -8 and so on up to +10, right? So this is the x-axis data for a discrete time, right? So now we'll go for generating impulse signal. So first I wish to name the figure by using a command called figure and open bracket, just in a single quotation you create a variable argument called a name, and I'm going to name this image as impulse signal. Okay, right? So first we'll create impulse signal in continuous time. Okay, so this is actually a command, so while you executing the program this line will not run, right? Okay, done. So now I already made a x-axis data. Now corresponding to this x-axis data I should build a amplitude, as we know that the impulse signal says the amplitude is equal to 1 whenever time t equal to 0, and all other time the amplitude has to be 0. That is the impulse function representation. Okay, let's see how we can create this, right? So before that I wish to plot impulse signal CT as well as in DT form in a single figure, right? In a single figure I want to see both of plot so that I can easily compare, right? So for that we have a command called subplot, so which is used to make a multiple plot on a single window. So it usually take 3 parameters. The first one is about how many rows you want to split up the plot window, and then second parameter is about how many column you want to split up. Third is about the position of the plot and what position you want to keep your plot. Okay, right? So this is the general 3 parameter the subplot is going to take. So let's say in our case I used to plot impulse signal in a continuous time on the first row, and then followed by impulse signal in a discrete time in the second row. So I wish to create 2 rows in a single column. I want to plot 2 signals. So I wish to keep my impulse signal in continuous time in the first position. So let's keep that as 1. Okay, done. Right, now I have to generate an amplitude. So as far as our impulse signal is concerned, the amplitude has to be equal to 1 when t equal to 0. So for that what I am going to do is I am going to use a logical operations. I am going to use a logical comparison operation, right? So I take the amplitude as, let's say, y1, which is amplitude of impulse signal in a continuous time. So which I am going to declare whenever t equal to 0. This is a logical operation, so this will check for each time step, right? So we have a around 20,001 data. For each of the time variable it is going to check whether it is equal to 0. So whenever it find this is equal to 0 and this condition is true, then it automatically takes that y1 as 1, and whereas all other cases it is a false, so it takes that particular data as 0, right? So which means we have around 20,000 one-time data over here, right? So for each time it will check one by one, and the moment the t equal to 0, it takes that particular portion y1 as 1, and all other it is going to keep it as 0, right? Again, I am keeping this as a semicolon because I don't want to display this in a command window. Right, now we have created a amplitude. So I repeat, as I said already, this is going to have amplitude for each of the time step. The y1 is equal to 1 whenever t equal to 0, and all other time that y1 equal to 0. So this is what actually is impulse signal is about, right? So now we go for plotting the signal. So in a MATLAB, to plot a two variable, we have a command called plot. So plot, first we have to call the x-axis data. So in our case, x-axis data is t. Then you should call for y-axis data. So y-axis data we will take it as y1. So this is going to make a impulse signal, right? So now I just label my x-axis data, y-axis data, and also I wish to keep the title for this plot. So to label the x-axis, we have a command called xlabel, and open bracket, in a single quotation you can give a name for the x-axis. So x-axis, let's keep the name as time. Then for y-axis we have to use a command called ylabel. Let's keep the name as amplitude, right? And then to name the plot, we should use a command called title, and open bracket, in single quotation you can name the plot. So I'm going to keep this plot as impulse signal in continuous time, right? Okay, so now we have created a impulse signal in continuous time. Now let's see how we can make this in a discrete time, right? So for a discrete time, I already have x-axis data, that is n data. Now let's see how we can create a amplitude. So right, okay, first I declare the plot position, right? Because we want to show both a plot in a single window, right? So use a subplot command again, 2 row 1 column. Now I wish to keep this in a second position, right? So let's keep that as 2. Done. Next, I need to create an amplitude. As in a discrete time, the amplitude of an impulse signal is equal to 1 whenever n equal to 0, and all other time the n is not equal to 0. So now I'm going to use the same operation we did for a continuous time. Okay, so let's assume the amplitude of impulse signal in a discrete time as, let's say, y2. So I'm going to make now y2 equal to 1 whenever n equal to 0. So I go with the same logical operation. So I'm checking for each of the n when it is equal to 0. So whenever n equal to 0, it automatically take that y2 as 1, and all other time it is going to take y2 as 0. So this is going to create again a row vector having size equal to the size of n, and it takes 1 when n equal to 0, and all other time it is going to take a 0 value. Right, now we have created the amplitude. Now I need to go for making a plot. So in MATLAB, to make a discrete plot, we should use a command called stem, okay, which is used to plot a discrete variables. So let's call stem, open bracket. First you need to declare x-axis data. So in our case it is a n. Then you need to call y-axis data. So we made actually y-axis amplitude as y2. So let's keep that y2. Right, now this is going to create a impulse signal. Now again, as we did in a continuous time, I wish to keep a label name and title, right? So let's copy this and paste. So x label is actually about samples, right? So let's keep this a sample, and the title is about impulse signal in discrete time. That's it. Right, now let's run this and let's see the signal. Yeah, you can see here you have plotted a impulse signal in CTS plus DT in a single window. So you see our figure name says impulse signal. This is actually impulse signal in CT. This is actually impulse signal in DT, discrete time, right? I hope you understood how we can generate impulse signal in MATLAB. Thank you.